Hello, I'm Guillermo and I contribute to Pyth. Today we're here to look at how you can integrate Pyth in your Solana smart contract. We're a first-party oracle, which means that our data comes right from the exchanges. Our publishers or market actors that will see the prices on the exchanges and publish them on-chain. Then our aggregation contract will take all these prices and aggregate them together, turn them into one single price that anyone can use. So here's our BTC USD page on our website. As you can see, we are publishing prices right now, and roughly every half a second there's a new price. You might see that there's a confidence band around the price. This is a feature that we're really proud of, and that is supposed to capture the uncertainty around the price. If you scroll down, you can see the prices of each publisher. So each of these keys represents a publisher. Whenever the publisher publishes, they will need to sign the price with this key. And as you can see, all these prices are changing at a really high frequency. That's because publishers are publishing new prices as of now. Once all these publishers' prices arrive on chain, our aggregation logic will make sure that the price we publish is robust, so that if any of these publishers misbehave, we still will get an accurate price. What I want to show today on my IDE is a really simple example that is going to use one of our price feeds. What I made here is an Anchor repository, so I'm using this Solana framework called Anchor that has become the standard for writing programs in Solana. And the idea of this program is, let's say I want to send a certain amount of dollars to my friend, but I want to send that in the native currency of Solana, which is Sol. That's because I don't want to bother swapping my Sol for a stable coin and then sending it to my friend. I would much rather be able to send it in native currency and not having to bother about swapping. To do that, obviously, I'm gonna need the Sol USD exchange rate. The first thing I'm gonna do, if I want to use a Pyth price feed, is import our crate. So I go to cargo.toml in my repository, and I'm gonna write Pyth SDK Solana as a dependency. Next, I need to know what is the price feed ID of Sol USD. This is a public key that uniquely identifies the price feed. So I'm gonna go to PythNetwork/developers/price feed IDs. I'm gonna choose the network where I want to use Pyth, in this case Solana DevNet, and I'm gonna look for Sol USD. And here it is. I can copy paste the price feed ID and I can use it here. So as you can see, this program has a single instruction, which is pay USD. This instruction is going to take one argument, which is the amount of USD that I want to send to my friend. The accounts that this instruction takes in are from who is the wallet sending to who is the wallet receiving. The price account that contains the Pyth price feed, and the system program who is going to get used to transfer Sol. And if we look at the code, these are the things I need to do to make sure that I'm actually using the right price and there's not going to be any security exploits in my contract. First, I need to check that the account that the user passed is actually the price account for Sol USD. The way I do that is by checking that the key of the account is equal to the price feed ID. So that's what I'm doing here. If the user passes a wrong price feed ID, this will all fail and everything will revert. Then I'm using these functions from the SDK to load the price into my contract. First, load price feed from account info. That is going to build this price feed object, and then get current price. Get current price is a function that checks the staleness of the price. If the price is stale, get current price will return none. And as you can see here in my code, if that's the case, I'm returning an error that says the price was down when the user called this contract. After this step, I'm sure the price is reliable and live. So now I'm able to compute how many lampers I need to send to my friend. So basically here what I'm doing is the math that is going to allow me to compute how many lampers correspond to the amount of USD that I want to send. So as you can see, I'm dividing the amount in dollars by the price. So basically what I'm doing here is I'm taking the amount in USD and dividing by the exchange rate, which is here. There's also some logic here around the exponent. Something that is important about Pyth price feeds is that they have a price component and an exponent component. And the actual real life price is going to be equal to price times 10 to the power of the exponent. That's why here I'm multiplying by 10 to the power of minus the exponent. I know this math ends up being a little bit complicated, but the viewer can check it. And now the only thing I need to do is create this transfer instruction. So I'm using a native Solana transfer from my pub key to my friend's pub key with the amount of lampers that I have computed. Without further ado, we're going to look at how we can run this code and make sure that everything is working. So what I'm going to do is I'm going to go to my browser and I'm going to use a wallet that is empty. So as you can see, this wallet doesn't have any SOL, and I'm going to try to send some SOL using my program. I'm going to need to copy the address first. I already wrote this TypeScript using the Anchor JavaScript SDK. This is written as an Anchor test, so I will just need to run Anchor test to run it. So I'm invoking the payUSD function with an argument of 1. That means I want to send $1 in SOL. And I'm just going to replace the to address by this new address that I've just created. And now I'm in my terminal. I'm just going to run Anchor test. First, my program is getting uploaded to DevNet. And now the transaction got executed. We can see that it was successful. And we can go to my Phantom wallet here and see that we received some SOL. So it worked. So we could also go to the Solana Explorer to make sure we can find this transaction. I find going to the Solana Explorer very useful because you can see everything that went on. And as you can see, the transfer is here. So our program was successful. The example is complete and you can find it on my GitHub. I hope this was useful to learn more about Pyth and how you can use it in your Solana program.